So the proposition that kind of brings this all together is that if B is a basis and PB is the matrix whose columns are the basis vectors, then to go from the weird vector back to normal is to multiply by PB. To go to the weird vector is to multiply by PB inverse, and both times we're multiplying on the left. Okay, and so an example, say you got this basis. Here's my basis. It consists of this vector and this vector and this vector. Well, I put those into the column of the matrix. And then let's say I've got this vector. So I'm starting off with like the weirder one. To get the original vector, you just multiply. Um, so multiply PB times x, that vector. So then you got matrix multiplication and you get this. This is x. Okay. Similarly, if I have x and I want to express it under the basis, then I multiply by PB inverse. Now, according to Sage, PB inverse is this. It looks kind of ugly because of all the fractions, but that's the way life is. And so I multiply that by 3, 1, -2, and I get 2, 1, 0. So this is x as a vector with the B basis. Okay, now let's look at here's looking at an applied example. So this is an example of wavelets. Supposed to work for a company that records its quarterly revenue in millions of dollars, as like quarter one is this much, quarter two is this much, quarter three is this much, quarter four is this much. Instead of using a table, you could use a vector. So like the vector is 10 threes, 13 1, 7 5, 8 2. And you can graph it here, where instead of graphing the vector in four-dimensional space, I'm just going to graph it with each entry as a number, as a dot plot. Okay. So that lets me graph like really high dimensional vectors in a way. It doesn't let me get a good glimpse of how different they are, but it does let me at least graph them. So that's an example of it graphed. Now, what about if I have this new basis? So basis for V1 is like, it's like looking at the average value, the yearly average. And then, so that's like the yearly average. And then V2 is going to be like the jump, the change from the first half of the year to the second half of the year. And then the third vector is going to be the jump between quarter one and quarter two. And um, and V4 will be the jump from quarter three to quarter four. So that means like put those vectors in as columns for PB. PB inverse is just compute the inverse in Sage. So for instance, like if I just have an arbitrary one here, then I like running it in, um, like running this times that gives me this. Look at that. That's the average. And this is like um, the average of half the average of the first half minus half the average of the second half. And then like average of the quarter one, quarter two, average of quarter three, quarter four, really not the average, but like the change. Okay. So say x is 10, 3, 13, 1, 7, 5, 8, 2. We'll compute that, multiply this matrix, the PB inverse times that, and you get this vector. Okay. So that means our revenue is written as like that plus that plus that plus that. Okay. Let's look at how that relates. So when you look at the first part, so this one right here, then that graph is like this blue line right here. It's the average value over the year. Now, once you add this scalar times V2, then you get the change in average revenue from the first half to the second half of the year. And then once you add in the V3 and the V4 with those scalars, then you'll get the change. So V3 is a negative and V4 is a negative, and they're both going up. So that means these become negative to like make it going up instead of down. And so then this basically means um, I've now got the whole vector described in this way. And so going back to here, my average revenue is per quarter is that, and then the 1.95 is like a decrease. It's like a decrease of that amount from first half to second half. This is the increase of that amount quarter one to quarter two, increase of that amount quarter three to quarter four. So it's like half the year and quarter one to quarter two and quarter three to quarter four. So it kind of describes more of the motion of the money. Okay, so that change of basis helps me kind of understand that data in a new light.